is a very interesting topic called managing technical debt. Those who've been around the software industry and Agile in particular, this topic has become somewhat more formalized in the last few years, and we all have come to have some kind of a general understanding. But what we'll do today is really dig a little deeper in this concept of technical debt and discuss how to best manage it and deal with it in various situations. I'm delighted to have back Michael Hall as a presenter. He's a regular presenter in this series of webinars. So let me give a quick introduction to those who have not had the chance to hear Mike in these webinars. Mike is CEO and founder of 3 Beacons and has been a regular practitioner of software for over 2 decades, both in developing software as well as leading software teams. And for last 10 years or so, he's been practicing Agile methods and coaching and mentoring various teams. So he is a good, solid person to talk to us about technical debt from various perspectives. So with that, I'm going to transfer control over to you, Mike, and so you can present.
Okay. Thank you very much, Hemant, and welcome to our audience. As Hemant was doing the introduction, I was sitting here thinking, I sure hope nobody thinks I'm an expert at technical debt. I don't think that's a good thing that people want to have. But today's seminar topic is on technical debt and how to use Agile methods in particular to help you manage technical debt and to help you avoid it. So it's my hope by the time that the hour is up that you have at least a few tangible techniques from the Agile world that you can use in dealing with technical debt. At the end of this seminar, we'll put the PDF version of this on the Synerzip website and also on my website for 3 Beacons. So feel free to download it, and that way you'll have a good reference as to some techniques for managing technical debt. Okay, with that, let's get started.
So, Mike, I'm not able to transfer control.
Okay.
To you, so
still don't have control.
Yeah.
Okay.
Let's use my laptop.
Okay.
So apologize for the technical glitch here, but Mike will just drive through
You bet.
his laptop. Yeah.
We're going to shift seats here, and okay. So I guess everyone's seeing slide 2 here, which is what is technical debt. Well, it's a term coined by Ward Cunningham, a very famous software engineer, in 1992. So the thing I would like the audience to do is to think back to times in your projects where you perhaps took the expedient route in doing some coding and implementation, and then how did that work out for the system from a longer term perspective? Oftentimes when we do that, if we don't immediately address that and make it righteous, it comes back to haunt us and can result in increased complexity and difficulty in maintaining the code down the road. Now I'm trying to advance slides here. How would I do that? Okay. Found the magic key. Thank you. And it's well, the technical debt metaphor is this. Basically, if you allow technical debt to creep into your system, you're basically using a credit card to obtain something right now, and basically you're saying, I'm going to pay for it later. If any of you listen to Dave Ramsey on the television, or he also has a radio show, he's a big proponent of being debt-free in your personal finances, and we can use that as an analogy in the software world also. You should always set the bar as high as you can, and the highest bar is we're going to build a system or a feature with 0 technical debt. Now oftentimes realistically that is hard to get to, but at least setting the bar there, the team knows what to strive for, and it will help minimize your technical debt. If you do allow technical debt to creep in, it does become like a ball and chain around your ankle, and it makes you less agile and less able to react to customer demands and future features. So just keep that in mind as you're considering making the right decision for no technical debt. Well, technical debt, the next slide, the consequences of basically comes about when you used what I'll call slapdash architecture, poor design, hasty coding versus rapid. Now, I want to make a very important distinction here. There's nothing wrong with rapid coding as long as it's done in conjunction with a rigorous quality plan and using agile methods. I once had a university math professor whose favorite motto was haste makes waste. So you can, if you use a hasty approach, chances are you're adding technical debt into your software. Looking at the picture, you know, here's a house that was built hastily with a very poor design. To get inside the house, you have to climb up the ladder. You have to balance yourself on that rickety platform. And then even worse, you have to shimmy up that pole on the other side to get to the front door. So maybe you've worked on a software system that felt like you had to jump through hoops in order to add what seems to be a simple feature, and primarily or likely due to technical debt. Okay, true or false question. All technical debt is bad and should be avoided at all costs. Usually when I do a seminar on this, most of these students answer, well, that's true. All of it's bad. We should avoid it at all costs. But in reality, the answer is false. There is some technical debt that is intentional, and I'll talk about that in just a minute. Let's talk about the types of technical debt. There are both unintentional and intentional, which is also subcategorized as short-term and long-term. If any of you have read any books by Steve McConnell, he categorizes technical debt in this manner, so I'll certainly give him credit for this. Let's talk a little bit about unintentional technical debt. Now, this is debt that is produced or introduced inadvertently, and some of the possible reasons for this might be lack of training. Maybe you've got the wrong skill mix on the team, a lack of understanding of the requirements perhaps, poor team collaboration, no culture of excellence, and possibly some other reasons. And examples of unintentional technical debt might be that a non-optimal architecture is chosen, or the wrong design approach is selected, or you've got a new team member on the team and they're currently writing poor code. Another example of unintentional debt might be that you've acquired or inherited a new code base with previously unidentified debt. Another example is, you know, if you're ever afforded the possibility of doing a platform rewrite, you may inadvertently create even more debt or a new kind of debt. So I'm sure there are others, but those are some examples of what I mean by unintentional technical debt. Now, for intentional technical debt, this is debt that actually is intended. It's a conscious decision to allow that for the present. Some possible reasons for intentional technical debt are things like schedule pressure, you know, a short-term focus, you know, maybe the size of efforts, maybe even just sheer laziness. There may be valid business reasons for intentional technical debt. For example, a startup company that has limited startup funding. They're very focused around developing a capability demonstration of some new technology so that their funders are impressed and can fund the company even further. You may also have a system which is near its end of life, So you just need a quick and dirty fix in there, and then 2 months down the road, the system's going to be end of life. So those are some valid reasons for a decision in favor of technical debt. From a short-term perspective, some examples might be, generic variable names, sparse comments, creating one class when you should create two, maybe a class method that goes on for 1,200 lines, not following coding conventions, this approach of hack it in and we'll fix it later. Even if you postpone documentation and postpone bug fix merges, that's even an example of intentional short-term technical debt. I'll give you a real-life example of a situation I faced a couple of years ago in inheriting a legacy code base. Every variable in the system was named C1, C2, C3, C4, and so on. And turns out that C5 was actually a T1 card port number that was currently servicing a voice over IP phone call. And it seemed like the rest of the team knew that, but I didn't. So you run into strange situations like that. Also, that same code base had a call state machine which had over 200 different states. Those of you that have ever done any telecommunications or telephony software, you know that the state machine is the critical aspect of that code. So we had this code base over 200 different states, and each state was named S-NNN, where NNN corresponded to 000 through 200. So you might get a feel for how difficult it would be to maintain that code, where you don't have good variable names. So that's just kind of a real-life example of some intentional short-term technical debt that I've seen recently. Continuing on, what are some examples, additional examples of short-term debt? For example, not writing test cases if you're a test-driven approach. If you add a comment that says to do, then that is intentional short-term debt. If you allow compiler warnings, that's intentional short-term debt. If you avoid static analysis and avoid things that kind of make up your quality plan, then that's also intentional short-term technical debt also. On the long-term side for intentional, one example is you've acquired a third-party code base that has some technical debt. You're aware of it, but it still makes good business sense to acquire that. So that's intentional long-term debt. Another one might be, if you have two systems that are interacting through some API or interoperability means, you may, you may plug in a placeholder converter for now between those two systems, and avoid the development cost of a better solution, and you would want to do that down the road. So I'm sure there's others, but those are some examples of some long-term technical debt. So with that, let's move on to the next slide. This is our technical debt quadrant. You can see it has 2 rows, intentional and unintentional, and 2 columns, reckless and prudent, and kind of some examples of what might happen there. And really, the thing I want to impress upon you is that only intentional, prudent technical debt is righteous. And you'll see the green check mark there with the asterisk. And the team may say something like, okay, we will ship on time due to customer demands and revenue opportunities, but we'll revise the quick fix as our top priority in the very next release. And so that's an example of when technical debt is allowed, and in my humble opinion, is the only time technical debt would be allowed. And again, it's in that upper right quadrant for intentional and prudent. Now, respect the asterisk. This is a little phrase I like to use with my existing team. It basically means allow short-term technical debt only if the commitment is there to schedule, prioritize, and fix it soon, as in the next sprint. And only allow long-term technical debt if the commitment is there to sponsor a project to resolve the debt. So if you have the type of environment where those types of commitments can be made and followed through on, then you can use technical debt to your advantage. Okay, let's talk about the cost of technical debt. Well, technical debt, if left unchecked, can eventually cripple your ability to write software or add features or even fix bugs. I'll give you a real-life example. I guess I should not name the major telecom company. They're no longer in business, but this major telecom company that I worked with for many years had a software base which all of their features were coded on top of. And this software base was basically spaghetti code. And it got to the point that it would take a year basically to add a small amount of code. I even talked to one of the engineers in the software base, and he told me that he wrote one line of code all of last year because it took that long to find exactly where that line of code should go, and then the testing aspects of it were horrendous. So that's what technical debt can do to your systems. And these are real-life examples. I'm not making any of this up. That company took a $10 million charge on their accounting books one year to do a rewrite of that software base. And the rewrite of that software base took 3 years and hundreds of engineers to do it. So this was not the only reason that that company went out of business, but I suspect it was a contributing factor. So, just a word to the wise there. It's a very serious topic, and we need to groom our software and continuously improve it to avoid the situation where a total rewrite has to be sponsored. Okay, continuing on, let's talk about some of the impacts of technical debt. Well, there's impacts to the person. If you go to work every morning and you have to work within a system that's riddled with technical debt, it reduces your job satisfaction. It'll reduce your motivation to do a great job. It can lead to feelings of frustration and helpfulness, and it can lead to eventually employee turnover. So it's a very serious topic. Technical debt also has impact to the team. It can slow down the team's velocity, weigh the team down. As I mentioned, it can cripple the team's ability to develop new features and makes it more difficult to hit a customer commitment or delivery. On the business side, technical debt can have a drastic impact to the business, as in the case study that I just referred to. It basically, every day that you do not fix the technical debt issue, it adds to the interest. And this interest payment means that you're paying more for interest than you should be, and your competition is paying more for additional features and new technologies. It can bring your business to a standstill, and it can lead to bad decisions made out of desperation. And I guess in the worst case, it can cause your company to go bankrupt if you consider that oftentimes software is a precious business commodity. Just a real quick, another case study is a few years ago I was working again in the telecom arena, and I'm still on this one. regarding impact to the business, we had a code base that was over 4 million lines of code. It was business phone systems. And when you built that code base, there were over 700,000 compiler warnings. The code itself had over 10,000 go-to statements, if you can imagine that. And I like to say it utilized the spaghetti design pattern. Originally when this software was developed, it was developed by a person that was not classically trained in software engineering. The guy was great, and he was mostly responsible for the business's early success that they had, because he could punch out a feature so quick. The problem was nobody could read his code. He did not really think about design patterns. He didn't worry about maintaining it. His job was to punch out features as quickly as possible and drive revenue for the company. And that worked, I guess, for the first 8 to 10 years. However, the 10 years after that, it was basically a disaster because, well, as you might have guessed, that person left the company, and then a team was left to deal with a huge code base that had a ton of technical debt. So from a business analyst perspective, the software was buggy. The new software breaks. When you develop new software, it breaks old features. The team is slow to respond. It's difficult to add new features. Various launches of new systems failed because of the poor quality of the software. A team of 30 developers, 15 are on support, which is a 50% interest payment. Sales down again, and questions on viability. Well, it all adds up to a strong possibility of going out of business. So that's a real life example that I saw a few years ago, and you just need to be aware of that. Okay, well, let's get to the meat of the presentation, which is some techniques, some tangible techniques for preventing technical debt. Now, the operative word here is for preventing. We're going to talk in just a few minutes about managing existing technical debt. But for right now, I want to talk about some agile methods that will help you prevent technical debt. The first technique for preventing technical debt is what I like to call draw the line. If you're in a leadership position or a scrum master or a VP of engineering or whatever, even from an engineering perspective, bottom up, you can help instill a mindset and an attitude that basically says, from this day forward, no technical debt. The only exception is for tactical or strategic, and as I said before, respect the asterisk. And so if you don't instill a mindset like that, then technical debt will continue to be accumulated. So you have to do what I believe the gentleman's name was William Barrett Travis did at the Alamo. You draw a line in the sand and say, okay, everybody that's with me, cross over the line. And from this point forward, no technical debt. Number 2, way to prevent technical debt. Well, embrace a strong definition of done within your organization. If you don't already have one for your project, start by choosing 2 or 3 of these things, such as coding standards, peer code reviews, static analysis, test-driven development, written unit tests, zero bugs, etc. Choose a few of those and just get started with a definition of done. Then, as you do the next project, take that existing definition of done and add one more item from this list to it. And then the next project, add one more item. If you'll do it that way, you will avoid the culture shock of, oh my gosh, all of this additional extra work to get a product out the door. And then you'll wake up 2 years from now and realize you've got a very strong definition of done. So this is a very common topic in Agile. called definition of done. Just make sure yours is very strong, and that will help prevent technical debt. I might also mention that you should do a definition of done for your user stories, your sprints, and your releases. So those 3 levels is what you should do a definition of done for. Third tangible technique for preventing technical debt is to use test-driven development, TDD. Now, studies show that TDD significantly reduces bugs and raises the overall quality of your software. It's a little bit different way of thinking. You know, it's kind of cart before the horse. You should write a unit test case first, run the code and fail it, and then write minimal code to make that test case pass, and then refactor afterwards. So it's an interesting agile technique that is getting a lot of play nowadays. One caveat, though, one possible disadvantage of this approach is that it does seem to, at least metrics and case studies show, that it does seem to take 10 to 15% longer to develop software when you're using a rigorous test-driven development approach. So just a word to the wise there. Number 4 technique for preventing technical debt is what I would call collaborative designs. Basically, the bottom line here is better designs come from collective wisdom than they come from the individual. So it's great to have subject matter experts, but challenge them and ask others to offer valuable input, and ask your subject matter experts to be willing to listen to others and incorporate their ideas also, in the spirit of the product wins. And regarding wisdom of the crowd, there's a great book out there by James, his last name is, I believe, pronounced Surowiecki. It's called Wisdom of the Crowds. It's a great book, and it gives a lot of real tangible examples of how crowd-based wisdom defeats individual wisdom all the time. Okay, so make sure your designs and architectures have a strong collaborative and consensus-based type approach. Okay, so that concludes. There's 4 techniques there for preventing technical debt. Let's move to the next topic of the seminar, which is techniques for managing new technical debt. Now, this is when you're working on a project and you're intentionally adding in new technical debt. Okay, we'll talk about inheriting legacy technical debt in just a minute. But this is, as your project's going on, how can you manage any new technical debt that is occurring on an ongoing basis? Okay, so let's jump into it. One very popular Agile technique is to use what's called a debt backlog. And again, this is when you introduce technical debt for a righteous reason. And the intent here is to make it visible by describing it on a tracking spreadsheet. That spreadsheet is called the debt backlog. Include an estimate for what it would take to remove that technical debt. Include the commitment, the stated commitment to do that refactoring or recoding, to follow through with that commitment. And so it's a spreadsheet. Here's actually an example of one I recently created for a team I'm currently working with at a Frisco-based company called WorldLink. We develop iPhone apps and Android apps, BlackBerry apps, mobile device apps, and one of our popular apps is called My Natural Healer. It lets you select, your current illness, and then it'll give you 10 natural healing remedies, from the worlds of herbalism, homeopathy, aromatherapy, and things like that. So if you look at the very bottom row on this debt backlog example, we had a situation that I noticed in the code that the same method handled both designating and undesignating a favorite. So if you look through that method, it had a lot of if statements. If it's designate, do this. If it's undesignate, do that. And 3 or 4 if statements that seemed unnecessary. So we felt like that code would be better refactored as separate methods, one for designate and one for undesignate. So the business justification was that, we did not notice that until it was right before a customer milestone. So the demo was coming up, so it was a little bit too risky to refactor and recode that right then. So we agreed that the debt was incurred in sprint 6. Our estimate for fixing that would be about 2 weeks. Turned out it was only 3 or 4 days, so it wasn't very bad. And then we listed out, what the work items were to bust out the undesignate into a separate method, add some logic in other parts of the code to know which method to call based on user action and things like that. And then in the commitment column, you'll see sprint 7, at worst sprint 8. And we did do this recoding in sprint 7. So this is just an example of how you can use a debt backlog to make your technical debt visible and track the commitment and ensure that these items go into your work backlog for your upcoming sprint. Number 2 technique for managing new technical debt is to create a mindset of servicing the debt. Always include technical debt items in upcoming sprints as soon as possible, and keep that mindset in line with fulfilling your commitment made. It does no good to add a debt item into the debt backlog if the commitment is not taken seriously and worked as planned. So it's one of those non-negotiable things. If it goes in the debt backlog, then the commitment, there might be a little bit of flexibility on the commitment, but the commitment is always followed through with. Okay. Number 3, make up stories. Well, this is where you basically write a story card. You're probably familiar with user stories. This is where you write a story card that basically apologizes to the code base. You basically tell the code base, I'm sorry, I mistreated you, but here's how I'm going to make it up to you. And it's a promise to fix it. So you add these make-up stories into your product backlog, right in there with the user stories and the other work items. And you prioritize them into the next sprint if at all possible. So it's a good way, again, to make it visible and to track it and to get them worked. An example of a make-up stories card, this is actually at a lower level. This is actually a sprint backlog example, and you'll see there the yellow highlighted work item called refactor and improve connection timeout. So as this project commenced, last sprint we incurred some technical debt in this area, and so we wrote a make-up story card and took a sprint task to make that right and to do the recoding and the improvement effort there. So you'll see how these agile techniques like product backlog and sprint backlog can actually be used to contain these apologetic makeup type activities. Next, number 4, an agile technique to managing new technical debt is to adopt, take an adoption approach. Now what this means is that basically if you're developing a user story that uses a part of the code that previously incurred technical debt, the make-up story card for that technical debt is fused with that new user story. And the user story cannot be worked unless the make-up story is also worked. So you just fuse them at the hip, and when the product owner chooses a particular user story, you remind the product owner that that has an adopted makeup story, and that therefore the time estimate for that will be a little bit longer. Okay, it's a good way to ensure that your makeup stories do get worked. Okay, that's number 4. Number 5, well, you can even define a dedicated sprint to service the technical debt. We've all, been involved where we've defined a specific bug fix sprint just to fix bugs. You can do the same thing just to drive down technical debt. Okay. Now, it's been my experience that this is a little bit harder sell than doing a bug fix sprint, but if you keep the technical debt items visible in your product backlog, in your sprint backlogs, and you're constantly socializing about those, then there's a lot more rationale to make a good decision to do an entire sprint to drive down the technical debt. Okay. All right, finally, let's talk about a few techniques for managing legacy technical debt. If you are not so lucky and get saddled with a code base, as I have in my previous life, that has a considerable amount of technical debt, then perhaps these techniques will resonate with you. The first one I've got here is called a redo project. And this actually does, it happens rarely. It's often a little bit difficult to justify, but at some point, if you get to the point where your code just is not able to continue performing, you just can't add features, a feature that should only take 1 month now takes 8 months, then you have to strongly consider sponsoring a redo project. Now, the most important thing on redo projects is this. You need to be very careful to not end up exchanging an apple for an orange. Now, by this, what I mean is if you did a redo project and all you did was introduce some new kind of technical debt, then shame on all of us, right? We shouldn't do that. So how do you do a redo project where you guarantee to the powers to be that the new system will not be riddled with that level of technical debt? Well, the way you do it is, once again, you use these agile techniques, you define a rigorous quality plan, you implement a strong definition of done, you do the iterative development, you have continuous improvement feedback loops, you use the Scrum mantra of inspection and adaption, and always have watchful eyes from your more experienced and Scrum Master type folks. So that's how you can help guarantee that your redo is not just exchanging an apple for an orange. Okay? Number 2 technique, use a small chunks approach. Now, this is a good approach when management will just not buy off on the cost and time of a redo project. You can say, well, okay, as we're developing these new features, let's take some time out and let's do a small chunks approach. Maybe this data manager portion of the system has always been troublesome. Let's see if we can't write a makeup story card on that, and let's spend some time redoing that area under a rigorous quality plan and using agile techniques. So, look for a natural abstraction point to contain the impact of the smaller, more focused redo. Effectively, you're doing a redo of a smaller area. And it's been my experience that these types of redos certainly happen more than total system redos. So that's another way you can use to manage legacy technical debt, and slowly but surely over time, the system that you're working on starts feeling better and better and better. Only if the new features that you're putting in there do not contribute to technical debt. If the new features you put in there are contributing heavily to technical debt, you're just spinning your wheels. Number 3 technique, managing legacy technical debt, is use this 70-30 rule. It's analogous to, patting your head and rubbing your stomach at the same time. You might take an approach of either 80-20 or 70-30 that says, okay, for our new feature development on this existing legacy code base, 70% of our effort will be around new user stories or new features. 30% will be around paying down the debt of a legacy system. And the most important thing if you're doing this is to make sure that you socialize that legacy code base improvements are actually part of this project. And ask for your management team's commitment and allow yourself to be held accountable to that. Okay, number 4 technique and last one is while there rule. We actually used this a couple of years ago at a company I was with and actually used it fairly successfully. We had a rule that went something like this. Okay, I'm working in an incredibly debt-burdened code base. Now, my job is to add a new feature. When I add a new feature, I have to go and touch various other methods or functions. Now, while I am there, I'm going to clean up that code and refactor it and make it according to our current quality plan. Okay, so yes, the feature development will take a little longer, but we had a while you're there rule that we actually did that. And we would go in there and we would take the C1, C2, C3 and convert those into meaningful variable names. We would, align the brackets. We would follow the coding standards and basically rewrite that function while we were there. And then slowly over time, you'll see that the system starts to shape up and it becomes healthier and more tangible from a business commodity perspective. Now, just a quick final thought on that case study that I mentioned a while ago about 4 million lines of code. We did the while you're there type rule, and we improved almost 50% of the 4 million lines of code. So about almost roughly at about 2 million lines of code we improved and brought up to our current quality standard. We did see a significant drop in the critical defects as reported from the customers. So yay, hurrah, big pats on the back for everybody. But the final caveat I'd like to remind you of is that in doing so, anytime you're redoing an existing function or method, you might introduce new bugs, and yes, we did. And it's a little bit embarrassing. Customers often wonder why taking a new software release with 10 new features, why does that cause one of their previous existing features to no longer work? Okay, so we found at least 10 new bugs on existing functionality, and it was a little bit embarrassing when those happened. And each time we had to, additionally justify our effort and why we were doing it, and again, ask for grace and recommitment to that. So, in conclusion, well, I can't say it any better than Robert Martin. You probably know him as Uncle Bob. He says, go well, not fast. And in my opinion, part of going well is to go rapid and as quickly as you can, as long as it's within the jurisdiction of a rigorous quality plan. You don't really have to be slow like a turtle. Using these agile methods, techniques that we've gone over here today, you can actually achieve a good, consistent, possibly rapid pace, and even more importantly, over time, your velocity will improve. So that kind of summarizes the conclusion. Couple of good references. Joshua Joshua's Refactoring the Patterns book is great. I mentioned Steve McConnell's Code Complete previously, and then another one, Metaphors We Live By, which all have some great things to say about technical debt. So with that, I'm done. I'm going to turn it back over to Mr. Hemant Elhans.
Thank you, Mike. This is an excellent discussion around thinking about technical debt and various tips and techniques to manage that debt effectively in various situations. So what we're going to do as usual right now is we're going to let you guys on the audience reflect upon what Mike just went through and capture and put your questions, if you haven't already, into the question Q&A panel. And what I'll do is I'll start reviewing those questions in a minute and pose those to Mike. And while you are doing the questions, I'll take a few minutes to just go through Synerzip introduction in just a couple of minutes. So those of you who don't know us, Synerzip is a software development partner working largely with small to mid-sized technology companies. We are technology agnostic and a domain agnostic company, and we work with small to mid-sized technology companies to help them do software product development as a partner to them. And for each client, we put together a dedicated team of high caliber software professionals so that the team can really have high productivity and follow some of the practices we talk about in agile practices like we just discussed, minimizing technical debt. And because of the way we approach software development with our experience, we believe we can really help our clients reduce the risk of software development and delivery, because we are able to put the appropriate level of discipline in software development. Overdoing it is also not good, and maverick development, as you all know, is not good. So the right amount of agile development is a good balance to strike that we help our clients do that. And the fourth point is, because of our dual shore operation, we have a development center in India and a small development center here in Austin and Dallas. We are able to provide 50% cost advantage in software development to our clients. And the last point is the flexibility that we are able to offer to our clients. Given our structure, we allow our clients, when they work with us, to take over the team that is working with them at Synerzip and to convert it into their captive operation whenever they feel like it. This is commonly known as build, operate, transfer option. So that's Synerzip in a nutshell. The next page, when it comes up, just shows you a glimpse of some of our clients. Most of these clients, as you see, the logos are small to mid-sized technology companies, largely focused around Austin, Dallas, Houston, but also on the East Coast and the West Coast. But almost all are small to mid-sized companies. So with that, I'm going to come to taking some questions from you guys, and I'm going to open the Q&A panel. Give me a minute to make sure we start with pick some questions which are more generally applicable to the broad audience. And there are a lot of questions here, so I'll have to just be, in the interest of time, take a few that will do the trick to drive the point home. So let's take the first question, Mike, related to the topic of technical debt. Is there, how would you characterize the definition and clarity of definition of what is technical debt? Is it a reasonably black and white definition that if two software professionals were to look at a piece of code, would they conclude same amount of technical debt, or is there a large amount of gray area? And how do you deal with that if it is gray area?
Yeah, I think when the term was first coined, technical debt, there was a lot of subjectiveness around what constitutes technical debt. You know, you may have one experienced engineer looking at the code that sees a considerable amount of technical debt, a less experienced or junior engineer that looks at code and says, I don't see any technical debt. So there is definitely a subjective aspect to technical debt. However, if you use these agile techniques and some of these that I've presented here, it helps reduce the ambiguity of that and helps clear up and makes it a lot more black and white as to whether or not your system has technical debt and to what level of technical debt it has. So this is definitely a step in the right direction. Use your agile method techniques and some of these things that I've gone over today to gain clarity on your technical debt situation.
Let's take a related question also about the measurement of technical debt. Can you talk a little bit about what's the guidance on best way to quantify and measure the magnitude of technical debt?
Okay. It's been my experience, one thing that works, if you are familiar with user stories, there's the user stories always have an estimate associated with them. Now, whether that's user story points or man hours is not really relevant to the question, but for example, if you identify some technical debt, and whether you log it in a debt backlog or write a make-up story card for it, you should always, as part of doing that, provide the estimate for what it will take you and or the team to resolve that. So so yes, you can measure technical debt by every time you add something to the debt backlog or create a make-up story card, it has an estimate. And then you go through and you add up all of the estimates for your technical debt activities that are still remaining. And then that will give you a total gauge in comparison with the entire project, as to how much technical debt is remaining or how much technical debt over the course of the project that you incurred and introduced. So it is definitely possible to measure technical debt as you go, and at any point in time, take a quick read of the metric associated with that.
All right, let's take another question, which is management education. It makes a lot of sense to be visible, keep the technical debt visible, but many of the senior management who are not quite up to speed on the realities of software development, how do you bring them into the fold in really appreciating and respecting the notion of technical debt?
Yeah. Well, that's a great question, and I'll try to answer it this way. We've all had the boss that just says, I want a whole bunch more features, and I want them done in a lot shorter time, and I don't care how it's done. I just want to be able to get out there and sell. I presented several real-life examples of where that can lead to disaster. So the way we manage upwards in a situation like that is to, number one, make sure your technical debt, as you incur it, is made visible. Add it to the product backlog, show it in your sprint backlogs, make up story cards, ... If you have inherited a legacy code base, it's always a good idea to do an upfront assessment of that code base and articulate the technical debt in terms of areas and potential estimates on how long it would take to fix each area. So, and then thirdly, I would say this, if any leader, director, VP, team lead, whoever, is really foolish enough to make a statement about, I really don't care how we get there, they're basically putting their job and your job in jeopardy in the future, because we just have to somehow socialize with them the importance of the criticality of the code base as a business commodity. Oftentimes, many companies, this is what makes that company profitable. Therefore, that code base is deserving of continuous improvement so that in the future it will be even easier to add features. Now, you have to balance it with new features versus spending time servicing technical debt, but I will admit to you, if you do not balance it and do not pay any attention to technical debt, you will eventually have a code base that you just can't use. And then what do? you take the $10 million annual charge on your books and redo it, and then 5 years later your company's out of business. So we have to do what we can to remind that person that perhaps is not as knowledgeable about software development and grooming of the code base. We have to remind them that it goes hand in hand with adding new features. Also, anytime a new feature is added, the code base should be refactored to better support that new feature. So oftentimes you can kind of, it's not really deleterious, it's just couching it within that kind of statement is some improvement and refactoring of the code base is necessary to allow that new feature to work well within the existing base.
Okay. So is there would you say there is some sort of an acceptable or an optimal level of technical debt that software teams can strive to achieve, even though achieving zero technical debt may be too much of a stretch target for them?
Yeah, and I'll just give you some answers from my experience. First of all, the target should be zero technical debt. Now, whether or not that's realistic, I think for small projects, maybe you're doing a small application, a reference application on a mobile device, or you're doing a website feature or something like that. Maybe that is realistically possible. I think the more complex the systems become, the more difficult it is to achieve zero technical debt. In my experience on complex systems, those that achieve single-digit percentage technical debt, like 9% or less, are in excellent shape for the future. Anything above 10% I would never recommend, because you're going to be spending a lot more time maintaining it than adding new features too. And just as a side note, I know I'm throwing out some percentages there. You know, you can think of it in terms of lines of code on the percentage, or in the overall effort, you know, in terms of estimating additional weeks that need to be put into the code base to get it back down to near zero technical debt.
Okay. So you're saying you could be measuring the debt in terms of story points as well as man hours or perhaps lines of code.
That's right. That's right. You can really measure it in any of those ways. You know, if you're familiar with user stories and you do story point estimation, then you can do something similar, you know, for technical debt makeup cards, which is based on size and complexity of the effort.
Let's take one final question. There are many here, but I think this one is a good one to drive the point home about the value. So from your experience, is there a concrete hard number that or anecdotally even, that you invested $100,000, let's say, in cleaning up a certain amount of technical debt, and that resulted in an improvement of reduced call volume, support call volumes, which ultimately resulted in a more than $200,000 improvement of the cost. So there's a clear ROI there. So is there other data that supports?
Well, yes, you have to have a good metrics program. You have to, you know, have both the before and after picture. So if you have metrics and you're tracking number of bugs and number of service affecting critical bugs out in the field in this certain area that you're addressing, and then you invest $100,000 to rewrite or refactor, recode that particular troublesome area, then you should be able to get a number of service affecting or critical bugs in that area after the fact also. So you just have to measure it before, and then you know the date and time at which that code got out to the field, and it's now in its improved form. Then measure it afterwards, and then you can do the before and after measurement. It's perhaps an even interesting follow-on question to that is, what if after the fact it still doesn't seem to you know, be any better? And for that, I would say, well, then you really need to go back and look at the techniques that you're using and agile methods, and make sure that they're as pure as possible and in the spirit of agile methods to gain the benefit of that effort.
Excellent. So thank you, Mike, for this webinar.
You're welcome.
Covered the entire time we had here, and this is an excellent topic. And all the audience, thank you for joining us, and we'll see you again next month in another Agile topic.